And good evening, everyone. It's good. I hope you're doing well. Today, I'm going to continue with the explanation of the problem number 4, the first class word. Just for to keep it a promise that in this word problem, I can give a label. This we call a physical science applications. Well, actually, this is a kind of problem will be a simple introduction of the physical science. Actually, you're going to learn with more details this subject in the next year when we're talking about the physics class. We're going to give the a most difficult analyze for any situations. But in this situation, we're talking about a physical science application because this is simply linear equations, system of linear equation solutions in one single state. All right, so and what is about this problem? Let's going to read the problem and analyze the situation. We have two runners, Thomas Alvarez and Melissa Spears, start driving at the same time. Well, this is a keyword in this situation because the problem says they're going to start driving at the same time. What does that mean? That means the time to spend Melissa, that's supposed to be equal. The time to spend Thomas to reach the final goal, destination, the final destination simple is in simple matter words because the problem mentioned start at the same time. So in both were going to driving in different cars, but in the same direction. For example, Melissa start from their house and going to Tegucigalpa. Probably same happened with Tomas. Okay, start from his house and goes to Tegucigalpa. But the most important thing to establish what will be the system and equation is because both subjects starting from the same time in different cars, but the same direction. According to the problem, Melissa has traveled a distance of 150 miles. Well, this is a illustration what the problem says. This is Melissa's house. This is the starting point. This is going to be the ending point, and she moves 150 miles. Meanwhile, Thomas, starting from his house, just for to give an example, start from his house and just driving only 120 miles. And what else? What information do we have according to Melissa? According to the Melissa, the problem mentioned if Melissa drove an average speed of 15 miles per hour faster than Thomas. We don't know what is the velocity of Tom, the speed of the Thomas in the car. However, the speed that the Melissa, I'm going to label over here, the velocity or speed of the Melissa, according for the situation, will be 15 miles per hour faster than the possible velocity of Thomas. This is the information that we got from Melissa. So the question is, we have to determine what will be the average speed of each car. In this situation, the average speed from Melissa and what will be the average speed or velocity from Thomas. Okay, what will be the application of physical science? Well, if you remember, every time that we are studying physical science, we learn to calculate the formula from the distance. Okay, the distance for any car of any particle is given by the product between the magnitude, the velocity or speed, multiplying by the period of time. Okay, I mean D equals B times T. And if you really want to looking for how many seconds, how many minutes, or how many hours to take into one body to move to another one, it's simple. The velocity, this is multiplying, passes to divide. So we can conclude distance divided by velocity, that will be equal the period of time. This is a physics formula how we can calculate the period of time from one body to move to one side to another one in some kind of distance and some kind of constant speed or velocity. Why is so useful this relationship at the moment we're going to start to solving this problem? Simple, because at the beginning of the problem mentioned Thomas and Melissa start driving at the same time. Okay, same time. What does that mean? That means I'm going to write the period of time of Thomas, right? That this letter T represents time and the capital T represents Thomas will be equal the period of time that Melissa. Okay, this is what the problem mentioned. They drive at the same time. Okay, now what we're going to do, we're going to replace those values. I mean, the formula from time is the division between the displacement divided by the speed or velocity. So I'm going to substitute the distance of Thomas, okay, divided by the velocity from Thomas, and that will be equal the distance of Melissa divided by the velocity or speed of Melissa, because this is the equivalent value of the formula for the period of time. Now, what we're going to do? Well, simple. We're going to replace the known variables. For example, what is the value from the total displacement of Thomas? Well, as soon as you can see in this diagram, or if you want to read the word problem, is 120 miles. Okay, 120 miles. What is the speed of Thomas? We have no idea. So we wrote, and we write BT equals. What will be the distance from Melissa? Well, as soon as you can see in this diagram, will be 150 miles. And divided by, instead to write velocity to Melissa, remember the problem what it says. Melissa drove an average speed of 15 miles per hour faster than Thomas. So BM equals 15 miles per hour plus velocity of Thomas. I'm going to replace, instead to write BM, I'm going to replace by that proportion. In this situation um, will be 15 miles per hour, adding the velocity of Thomas. And we are creating a proportion. Remember proportion because we have two fraction equations. And as soon as you remember, we can perfectly apply cross multiplication to trying to solving these proportions. Remember, this quantities divide passes to multiply. We got 120 miles multiplied by 15 miles per hour plus velocity of Thomas. And this is going to be equal 150 miles, okay, multiplied by the velocity of Thomas. Cross multiplication. This quantities divide, passes to multiply, and this quantities divide, passes to multiply. And until this moment, we can proceed in two ways. The first one, we can apply distributive property and solving for like terms. Okay, this is a one way. And if you want to simplify this expression, in my case, I'd rather to apply with this method because 120 can be multiplied, it can passes to divide. So I'm going to destroy the parenthesis because there's not going to be additional number who's multiplying this expression. So we got 15 miles per hour plus the velocity of Thomas will be equal to 150, and the units miles with miles can be canceled. Divided by 120, and this is going to be the velocity of Thomas. How we can proceed in this situation? Okay, let me share the screen. Okay, and let me show you how you're supposed to proceed to solving this problem using the calculator. Okay, for example, this is the Pricky apps, not the scientific calculator. All right. And as soon as you can see this application, okay, we can divide, if you wish, we can divide the quantity 150 divided by 120. 150 divided by 120, and the fraction will be 5 over 4, and that means this is going to be equal 1.25 units, okay? So we can divide these two quantities and the result will be 1.25, okay? So 15 miles per hour plus the speed of Thomas, that will be equal, once again, remember the answer that's supposed to be, once again, 1.25 units, okay? 1.25. 1.25 what? Velocity of Thomas. Remember, at the moment we're going to divide 150 miles divided by 120 miles, we can cancel the units and we can reduce this number, okay? So what we're going to do, we have a linear equation, right? So we can perfectly solve by the velocity of Thomas because this is quantity is adding passes to subtracting, and we got the number one imaginary number. So we got 50 miles per hour equals 1.25 velocity of Thomas subtracting velocity of Thomas. Even though you're not seeing what kind of number is this is an imaginary negative number one. So if you subtract 1.25 minus 1, that will be equal to 0.25. And we got 15 miles per hour equals 0.25 times the velocity of Thomas. And because this quantity is multiplying, passes to divide. And if you divide 15 divided by 0.25, the answer will be 60 miles per hour. This is going to be the average speed of Thomas. Okay. And remember, the problem asking for what will be the average velocity from Thomas, and even though what will be the average velocity from Melissa. And because we know what is the average velocity of Thomas, we can continue with this green one equation and substitute this value. I mean, the Melissa velocity with speed will be given by 15 miles per hour, adding the 60 miles per hour of Thomas. So we can conclude Melissa drove 55 miles per hour. And this is going to be the solution set of the problem. Okay, guys, remember, every time that we're going to proceed to solving this kind of problems, it could be not necessary, not mandatory, but it could be a great idea to perform a free body diagram. A free body diagram, I mean, is an illustration what the word problem mentioned in one singular picture. Remember, one picture is 1,000 times value than any words. Okay, so this is going to be easier at the moment. We're going to apply this situation. Okay, and with this makes sense because if you are driving faster than another people, you're going to moving more distance than another one who's moving slower, right? And that's why Thomas is driving, he's moving only 120 miles because he's moving 15 miles per hour slower than Melissa. And if you want to check the answer, we're supposed to have the same time, right? So the only thing that we have to do is divide any quantity. For example, if you really want to know what will be the period of time of Thomas, the only thing that we have to do is divide 120 divided by 60, okay? And if you divide 120 divided by 60, that will be 2 hours. And if you want to know what will be the period of time of Melissa, you have to divide 150 divided by 75, and that will be 2 hours. So in this moment, both cars, Melissa and Thomas, takes around 2 hours to reach their final destiny. Okay, only Melissa drove 150 miles and displacement of 150 miles and a velocity of 75 miles per hour. Meanwhile, Thomas, his displacement was around 120 miles. The time of the final destination also 2 hours because they're starting at the same time. However, but the average speed of Thomas' car was only 60 miles per hour. Okay, guys, thank you so much for your attendance. Have a great and wonderful day. If you like the video, just, well, if you enjoyed the video, please push the like button and subscribe, right? Thank you so much. Have a great and wonderful night. Take care of yourself.